Hi, my name is Camila Zamora and this is my Physics 2211 Lab 5 report on the falling slinky. So, a quick introduction to this lab is that it was about an experiment of the falling slinky and seeing what happened when you drop the slinky. So for this, I used the tracker software to track the slinky and also created a computational model using GlowScript. With this, you can see that the position graph was a horizontal position graph at first, and after the slinky completely compressed, you have a downward sloping line. So in this experiment, the system was the slinky, and the surroundings would be the earth and the air. A few important physics concepts for this lab. The most important one was the momentum update formula and the position update formula, which were used to track and iterate the velocity and the position of the slinky. Another important one was tension and the spring force, where we can assume the spring force and the internal spring force by the slinky can be thought as a tension force acting on the bottom of the slinky. And finally, we have the drag force with its corresponding formula. So first, I started with the tracker software and I decided to put the origin at the bottom of the slinky and track the motion from there. Then I modeled this in the GlowScript code, which I set the position on the bottom of the slinky at the C origin, and the velocity of the bottom of the slinky was also 0. And finally, the drag coefficient was set to 2.6. Then I created two different loops. In the first one, we can see before the slinky completely compressed itself, we have essentially a tension force counteracting with the weight at the bottom of the slinky, which caused it not to move at all. And after it fully compresses, then you can see the forces of weight and drag, and there is a net force, a downward one, that will cause the bottom of the slinky to move downwards. So here are my results of my tracker versus the GlowScript. In this case, the GlowScript would be the orange line and the tracker would be the red line. And as you can see, there's more discrepancy between the tracker and the GlowScript models. This could be because there's more drag in the video than in the model, or also just a human error when trying to do the tracker model. So, a few conclusions. The graphs themselves were very similar to each other, but there were some slight discrepancy as we saw in the last slide. And so this could be due to a few sources of error. For example, the angle of the video and also the speed of the video, especially because the video was slowed down and wasn't put in slow motion. Also, there could be human error within the tracker tracking the motion of the slinky. But this graph was very interesting, seeing as even though the slinky was dropped, the bottom of the slinky did not move until the whole slinky itself was compressed. So for the what if and what does it mean questions. So what if and what does it mean for the bottom of the slinky to be at rest until the slinky fully compresses? So this means that the internal forces of the slinky keep the bottom of the slinky up at rest until the top of the slinky fully compresses and reaches the bottom of the slinky. So at that point, the bottom of the slinky does fully move downward, but this is because of, as I said before, the internal forces within the slinky and the spring force between the bottom and the top of the slinky. And what if you were to model the slinky as a point mass in the slinky center of mass? So then both the velocity and the position graphs will be different. So you have a concave down position graph and a downwardly sloping velocity graph. This would be like this because you have a point of mass falling with a small amount of drag, similar to what you can see in the second while loop as the slinky is falling fully compressed. Thank you.